Okay, welcome back. We have a couple more examples. This example 3 is going to be a little bit long, but I think it'll really help. Okay, so the first thing we want to do is calculate the resultant components like we did in the last one. And then we want to calculate the magnitude and direction of that resultant vector. Okay, so I'm going to be working in the whiteboard again. Okay, so our first step is going to be to break this down. Okay, and we are looking at our resultant being each of the vectors added together. Okay, so let me just write that down for us. That way we don't forget our goal. Okay, so again, we can break this down into our components like we did before, Rx and Ry. Okay, Rx is going to be the x component of A, the x component of B, and the x component of C, adding those together. Same thing with our y. Okay, so we want to start analyzing our picture here. Okay, and we have our given magnitudes of each of these vectors. Okay, so it might be a little bit disproportionate, but that's okay. All right, so we want to break down A first, okay? So we have A equals AX plus AY, okay? We will start looking at this triangle here since we have this angle, okay? So this is our X axis, this is our Y axis. We have our AX component here. It's our AX and our AY right here. Okay, so again, using trigonomic identities, we can find these components. So let's see. We have our A and we need our AX and AY. So we have our adjacent and our opposite that we need to solve for. So our adjacent, AX over A, adjacent over hypotenuse is going to be cosine theta. Okay. And again, we're solving for AX, A cosine theta. Okay, plugging in our numbers, we see that this is 41.0. Our theta is 29 degrees. Okay, we get our calculator out. 41 times cosine 29 degrees. We get that that equals 35.9 kilometers. Okay. I should have wrote that down. Kilometers. Okay. So now we have our AX. Our AY is going to be solved in a similar way. Okay, AY is going to equal A times sine, because we have opposite and hypotenuse. So it's going to be sine of theta. Okay, plugging in those numbers again, but now with the sine, we get 19.9 kilometers. Okay, so now we have our AX and our AY. We will continue this going around. We can look at B. So we have a BX and, oops, my bad. I meant to draw BY right there. BY and a BX. Okay, do the exact same thing. We have this angle here, beta, and we have our hypotenuse. We want our opposite and our adjacent. And it looks very similar to this, except for it's in the opposite direction. Okay, it's in a different quadrant over here. Okay, so we'll add this down here. B is again bx and by. Bx over b, that is adjacent over hypotenuse. Okay, so adjacent over hypotenuse is going to be our cosine of beta. Okay, we can solve for our bx using algebra. And then we'll input our values here. So b, we've got 24.5 kilometers. And our angle here is 54 degrees. 54 degrees. Okay. Use our calculator, 24.5 times cosine of 54 degrees. We get 14.4 kilometers. Okay. Do the exact same thing for by. And we can see that it's going to be our opposite over adjacent. So that's going to be sine of beta. Okay, insert those numbers, use your calculator, and you should get 19.8 kilometers. Okay, and while you're doing this, make sure that you're actually doing it with me. It'll help a lot in the future if you can understand how I'm doing it and how I'm inputting it into the calculator. Okay, so you want to make sure that you are practicing this as well. Okay, so we have our by, our bx, we have our ax, and we have our ay. Now we want to know our c. So we have our c equals cx plus cy. Okay. Oh, I forgot one thing when looking at our b here. Notice that we are in this second quadrant here. If you guys remember algebra, this would be our first quadrant, second quadrant, third quadrant, and fourth quadrant when we're looking at a XY graph. Okay, we're in our second quadrant for our b vector. Okay, this is important because it's telling you in which direction our bx and our by are. So our by, it's in the positive y quadrants, okay? But our bx is in our negative quadrants, okay? So we will have to manually input that into our answer for bx, okay? So again, by is positive because this is our positive y. Everything above the x-axis is positive y. Everything to the left of the y-axis over here, that's all negative x. Okay, so we need to input this manually. This is a negative value. Okay, so down here, I'm going to put a negative sign here. So watch out for that. And this other one is still positive. So that one's okay. Okay, now looking at our c vector, we don't have an x component like we saw earlier in a different example. We don't have an x component, but we do have a y component, okay? And that y component, as you can see, is in either the third or the fourth quadrant. It's kind of on both. And that means that it is negative as well, okay? So our cy is actually going to be negative, and we have our value here is 31.0 kilometers. Okay. All right, so now we have solved for everything that we need to build our resultant vector. Okay, so I'm gonna scooch over here and start putting in my numbers. So we have 8x, which we solve for here as 35.9 kilometers. Okay. Now we need our bx, which we have down here, negative 14.4. Let me kind of fix this guy up. 14.4, negative 14.4 kilometers. Okay, I like to do it this way where it's adding a negative. Makes sense to me. Okay, and cx, there is no cx, that's 0, so we don't have to worry about that. Okay, so we add these two numbers, or subtract in this case, 35.9 minus 14.4, and we get 21.5 kilometers. Okay, so we'll do the exact same thing for ry. So AY we solve for as 19.9 kilometers. Our BY we solve for as 19.8. Oops. 19.8 kilometers. And our CY we know is 31 kilometers, but again, it's in that negative direction. Okay. So we have negative 31.0 kilometers. Okay, we add these together, 19.9, 19.8 minus 31, and we get 8.7 kilometers. Okay, so these are our components, okay, and we want to make sure that we are answering the questions. So what is it asking first? First, it's saying we want to know the resultant components, and that's what we just did. Boom and boom. Okay. Second question, calculate the magnitude and the direction of the resultant. Okay, so this is where it might get a little bit more tricky. Okay, so our first thing is going to be calculating our magnitude. Now, our magnitude is going to be done through using the Pythagorean theorem. Okay, so our Pythagorean theorem is typically, actually let me do it, is going to be a squared plus b squared equals c squared. Okay, this is our typical Pythagorean theorem. Given a right triangle with two sides and a hypotenuse. Okay, now we're given this exact same thing. Okay, we are given our r, which would be like our c. Okay, now I don't know which directions these are in yet, but I'm just going to build this. So we have our r. Okay, we have our a, which would be like our x component, and our b, which would be like our y component. Okay, so we're going to build it the exact same way. So a squared would be rx squared. B squared is going to be ry squared equals c squared. Our hypotenuse is going to be r squared. Okay, now we can solve for our magnitude. R equals the square root of rx squared plus ry squared. Okay, and then plug our numbers in there. So we're going to have 21.5 squared plus 8.7 squared, and all of that inside of a square root. Okay, so we'll take our calculator, and hopefully you can find your square root sign. Sometimes it can be a little bit tricky, but get your square root up, then put in your numbers. So 21.5 squared plus 8.7 squared, close my parentheses, and I end up with my resultant as 23.2 kilometers. Okay, so this is my resultant. Okay, all right. Now we want to know our direction. So This is going to involve a little bit of trig and a little bit of drawing, okay, to help visualize. So if I back up here and I look at my whole picture, wow, that's a lot of math. I want to first draw this out, okay, because right now I know my R, but I don't really know what it's going to look like. So I go back and I think of how would I draw this graphically? Okay, so I'm going to use the tip to tail method to put it all into one big picture, okay? So I have my A. Now again, this is not going to be perfect because I'm drawing this out. Okay, so be lenient on me. Okay, so I have my A. I'm going to draw it. Let's see, let me get a little bit of a y-axis here, an x-axis. It kind of helped me. Okay, so I have my A at about 29 degrees. Okay, then I have, I'm adding my B. Okay, so again, tip to tail method. I'm going to say about, right about here. There's my B, okay? And then my C goes straight down, so that one's a little easier to draw. Okay, so there's my C, my B, and my A. Okay, now my resultant vector is going to be from tip to tail, right about there. Okay, so this is my resultant vector. Maybe I should draw it in a different color. Okay, that's my resultant vector that I'm looking at. Let me just start over. There we go. Okay, so that's my resultant vector. So my R that I'm looking at, that's 23.2 kilometers, is about that. Okay, so now let me zoom back in. Okay, now, again, I want to know my direction. So if I kind of ignore the C and the B and the A, I can now look at this whole thing, this whole picture here. Okay, I know that this is Y again, this is X. This component here is my R, Y, and this component here along the x-axis is Rx, okay? And what it means by what direction, the direction is given by that angle that we've been looking at a lot, theta. Okay, so I'm going to define this angle as alpha, okay, just another Greek letter. Not very important, but I'm just going to define that guy there. And that's going to tell me which direction my R, my resultant vector, is in, okay? So I know my Rx and I know my Ry, so I'm going to use those two to solve for my alpha. Okay, and again, this is going to be using my trig identities. Okay, so if I'm looking at this angle here, and I know this guy, that is going to be my opposite, and this other one here, Rx, is going to be my adjacent. Okay, so I know opposite, and I know adjacent. Okay, so which trig identity is opposite over adjacent? Tangent, right? So tan of alpha is going to be our opposite over adjacent. Okay? So I should just go this way. There we go. Okay. So that's going to be Ry over Rx. Okay? Now, we can either put our numbers in now, or I can do a little bit of trigonometry and solve for alpha and then put my numbers in. That's the way I prefer to do it. I like to have all of my little math done, I like to say, before I do the calculation. So what I'm going to do is I'm going to draw this out again. Tan of alpha equals Ry over Rx. So how I get alpha alone on this side is I take the inverse tangent of both sides. Okay, now hopefully you guys have heard of this. If not, it's inverse tangent or called arctan as well. This is just some little bit of trig that I haven't discussed yet, but here we have it. And this will cross out with that, and we will be left with just alpha. Okay, so let me plug in my numbers now. So I have alpha equals tan inverse of Ry. Our Ry was 8.7. 8.7. And our Rx was 21.5. 21.5. Okay. And now we go to our calculator. And this one might be a little tricky to find. If you have one of these kind of calculators, it's right where the tangent is as well. You'll just have to push the second button first. So second tangent, and then plug in our numbers. 8.7 divided by 21.5. And we get our angle as 22.0 degrees. Ooh. Degrees. Okay. So now there's our direction and our magnitude and direction. And that describes our vector. Okay? All right. So one last thing I want to look at is going to be this last example, which is going to be very, very similar. Okay? The only difference is, my R, oh geez, if I can get this. My R is now going to be A minus B plus C. Okay, so all of our magnitudes are going to be about the same, but our algebra here is going to be different. Okay, so we have now R equals A minus B plus C. Okay, so Rx is going to be equal to A, which is again 35.9 kilometers, minus our B, which we already had as negative 14.4. Okay, but now it's in the opposite direction. Okay, plus our CX, which is 0. Okay, so now we have our 35.9 plus 14 plus 14.4, and that's going to be 50.3 kilometers. Okay, and do the same thing with RY. We have our 19.9 kilometers. That's our AX. Oops. Minus our B, which is 19.8. Kilometers. And adding our C, which is negative 31 kilometers. Okay. So 19.9, 17.8, 31. That's going to be 30.9 kilometers. Okay, so see how different that one little minus changed, our Rx and our Ry. Okay. Now we can do the exact same thing as before. Okay, we can use the Pythagorean theorem to solve for our magnitude of R. So we have our Rx, 50.3 squared, This should be a minus. Let's see. That should be a minus right there. Sorry about that. Okay. Plus our negative 30.9 squared. And remember, when it's a negative times a negative, you get a positive. So the minus doesn't really matter right now, but it will when we're trying to figure out our angle. So put this into our calculator. 50.3 squared plus 30.9 squared. We get 59.0 kilometers. Okay, so that is now our resultant magnitude. And now we want to know our direction. Okay, so we'll do a similar thing here, but our picture is going to look a little different. So let me do a similar thing to what I did before. Okay, we have our A going in that direction. That's our A. Now our B is going to be in the complete opposite direction here. Okay, so it's going to be the same magnitude, but it's going to be in the opposite direction. Okay, so again, tip to tail, we're going to have something about like that for B. Okay, and then C is still going to be down. We're just adding C. Okay, now our resultant vector from here, tip to tail. Ooh, that wasn't very good. Let's try that again. Tip to tail. Okay, I'm a little off, but that's okay. All right, so we can analyze it just like we did before. Remember that this right here is our RY. This is going to be our RX on this side. Okay, and then this will be some angle alpha. Okay, all right, so we're going to do the exact same thing as we did before, even though we have like a different looking triangle. Okay, all right, so oops. We have, we know our hypotenuse length. Okay, that's our magnitude that we just solved for. Now we need to find our, let's see, this would be our opposite. RY is our opposite, and our adjacent is RX. So what we'll do is we'll say RX over R. This is going to be our, actually, we can do this like we did over here. Okay, so we have our opposite, RY, divided by our adjacent, RX, because both of those we solved for and we know them. Okay, and that's going to be tangent of alpha, just like last time. Okay, but we're going to get a different value. So remember, we can solve in this way. Tan inverse of RY over RX equals alpha. Okay, then we can put our numbers in. So alpha equals tangent inverse of RY, which was 50.3, divided by our RX. Oops, I did that backwards. Sorry about that. Okay, RY, that's going to be this guy here. This one was RY. Okay, so we have our negative 30.9 divided by 50.3. And don't forget that negative. That negative is going to affect the answer, okay? So be careful with that. Okay, so we input this into our calculator, negative 30.9 divided by 50.3, and we get a negative 31.6 degrees. Whoops. Okay, so that is our alpha right here. Negative 31.6. Okay, so This negative, let me explain that. This is going to tell you the direction in which your angle is being measured. Okay, so we start at our x-axis typically, and usually we go this way when we are trying to measure angles. Okay, we say, you know, we go to 45 degrees, we go to, I don't know, 180, right? We go all the way over here to 180. We go all the way around for 360, okay, 360 degrees. In this scenario, what we normally do is we're usually moving counterclockwise, okay? This negative is telling me, oh, I need to move in the opposite direction. So I need to move clockwise, okay? So watch out for that. Just know that we can also look at this in a different way. If I take my negative, I can convert it to the counterclockwise measure just by adding 360 degrees. So I can take my 31.6 degrees, degrees, and add 360, basically adding a circle, right? And that'll tell me this big giant angle here, but they represent the exact same thing. So you don't have to do this. You can keep it there. If that makes sense to you, that's totally fine. It works for me too, okay? But let's see, if I add 360 to this, I would get 328.4 degrees. So whichever way you'd prefer, it doesn't matter, okay? All right, so I know that was a lot of examples, but I did want to kind of go through a few with you guys in a lot of detail. That way, once I do have a homework up and a progress quiz, that you guys will, you know, understand and be able to do it on your own, hopefully. But if not, feel free to email me or message me on Canvas, whichever one works for you. You can get in touch with me pretty quickly. Again, just give me, you know, 24 to 48 hours and I'll be able to answer you guys, no problem. All right? All right, let me know if you guys have questions and have a good weekend.